So the first question is here. Some are going to be theory, others we are going to calculate. So number 1, so that's the first question. Give one example of a longitudinal wave. It's carrying 1 mark. We think that longitudinal waves are waves whose vibration of particles is parallel to the direction of wave travel, and we gave one example of a longitudinal wave. Which one is that? The sound wave. That's okay. We move on to question number 2. So that's our question number 2. We are told that the audible frequency for a certain person is 30 Hertz and 16,500 Hertz. So we are told to determine the largest wavelength, because here we are going to determine wavelength in 2 ways, in 2 positions, whereby the frequency is 30 and where it is 16,500. So we are told to determine the largest wavelength of sound in air the person can detect. And we have been given the speed of sound in air to be 330 meters per second. So we can first approach it by first calculating the wavelength when the frequency is 30 and the wavelength when the frequency is 16,500, and then we are going to pick the largest, because here we'll have the largest wavelength. Or we can simply come and say we know that the wave equation V is equal to frequency multiplied by the wavelength, and therefore we say if we make frequency the subject of the formula, then it means that we are going to have the speed divided by the wavelength. And therefore we can say that we are told to determine the largest wavelength. So if the wavelength is largest, if here we have the largest wavelength, then it means we are going to have the minimum frequency. So we just come and use the frequency when it is minimum. That is when it will give us the largest wavelength. So we just come and use this frequency, because that is what is going to give us the minimum frequency. Because we are told that the range, the audible frequency for a certain person is 30 Hertz and 16,500 Hertz. So we are told to determine the largest wavelength of sound in air the person can detect. So the largest wavelength will be when the frequency is smallest. So we simply come and apply the wave equation. So we are going to use the smallest frequency here. So our frequency, we are going to use it as 30 Hertz. Then we are told that the speed of sound, V, is 330 meters per second. So we want to get the wavelength. And in our case, we are saying it is the largest wavelength because the frequency is smallest. So in our formula, V is equal to wavelength multiplied by frequency. We can make wavelength the subject of the formula, which will be equal to the speed divided by the frequency. So we are going to have our V as, we have it as 330 meters per second divided by the smallest frequency or the smaller frequency, which is 30 Hertz. So when we divide this, we can cancel the 0 and the 0, 33 over 3, we get 11 meters. So that will be our largest wavelength that the person can detect. Because when you use this other one, 16,500 Hertz, then it means that we are going to have the minimum or the smallest wavelength. So our largest wavelength is 11 meters.